Hey guys, Mr. Backerberg here. In this video, we're going to look at a cosine of a sum or a difference. Now, when we're doing trig with angles, not every angle can be evaluated using our unit circle, but sometimes we can use our unit circle in a little bit of a different way to help us out. So we're going to look at cosine sum and difference formulas here. So if we wanted to evaluate the cosine of an angle that didn't show up on our unit circle, but say there was a way for us to rewrite that angle as either a sum or a difference of two angles that do show up on our unit circle, then we're going to be able to apply one of these formulas. So in the first one, we've got the cosine of u plus v, so we can split that up into the cosine of u times the cosine of v minus the sine of u times the sine of v. Or if we had the cosine of u minus v, then we'd split that up into the cosine of u times the cosine of v plus the sine of u sine of v. So in this example, we're going to try to evaluate the cosine of a 15-degree angle using our unit circle. But 15 degrees itself does not show up on the unit circle. But here's what we can do. As we're thinking about this 15, as we're doing the cosine, I could think about 15 as being 45 minus 30. So then we've got the cosine of a subtraction problem. So this is going to be our cosine of a difference identity. So in here, the 45 is going to be my u value, and the 30 is going to be my v value. So using that formula, we would do the cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. Now what we can do is we can evaluate each one of these sine and cosine pieces individually using our unit circle. So the cosine of a 45-degree angle is root 2 over 2. The cosine of a 30-degree angle is root 3 over 2 plus sine of 45 is root 2 over 2, and the sine of 30 is 1/2. Now we're going to multiply these together. So as we're multiplying these radicals in the front, we multiply the numbers underneath the radical, and we keep the square root on it. So that's going to be the square root of 6 over 4, plus on the back end, if I take root 2 times 1, that's just root 2 over 4. But now as we take a look at our fractions, they have common denominators, so we're going to be able to put them together. So I can write this as the square root of 6 plus the square root of 2 all over 4. Now I cannot combine the square root of 6 and the square root of 2 on top because they have different numbers underneath their radical. So I'm just going to leave this as my final answer. Now as we're taking a look at this example, we're going to end up using our cosine sum formula to help us evaluate the cosine of 7 pi over 12. So we're going to look at that 7 pi over 12, and we're going to see if we can break that into smaller angles being added together that we can then find on our unit circle. So this is a cosine. Now I'm going to focus on the numerator, and I want to think of ways to get to 7 pi. And the way that I'm going to use is I'm going to go with a 4 pi and a 3 pi, but each one of these has to be over 12 since that's our denominator. Now these fractions are actually reducible. This 4 pi over 12 ends up reducing down to pi over 3, and this 3 pi over 12 ends up reducing down to pi over 4. So I can think about this 7 pi over 12 as being the cosine of pi over 3 plus pi over 4. So pi over 3 is going to be my u value, and pi over 4 is going to be my v value. So I would do the cosine of pi over 3 times the cosine of pi over 4 minus the sine of pi over 3 times the sine of pi over 4. And now we're going to use our unit circle to help us evaluate each one of these individually. So the cosine of pi over 3 is 1/2. The cosine of pi over 4 is root 2 over 2 minus the sine of pi over 3, which is root 3 over 2, and the sine of pi over 4 is root 2 over 2. Now we're going to multiply these together. So 1/2 times root 2 over 2 should give me root 2 over 4. And then root 3 over 2 times root 2 over 2 should give me root 6 over 4. Now because our fractions have common denominators, we can put them together to get root 2 minus root 6 all over 4. Now again, because we've got different numbers underneath the radicals, we're not going to be able to actually do the subtraction on top of the fraction. So we're just going to leave this as our final answer. Now we can also use these identities to help us condense down trig expressions. So here we have the cosine of 62 degrees times the cosine of 17 degrees plus the sine of 62 degrees times the sine of 17 degrees. So this looks like our cosine difference formula. So in here, that 62 degrees is going to be my u value, and the 17 degrees is going to be my v value. So I can condense this down to be the cosine of 62 degrees minus 17 degrees. But if we do that subtraction inside of our parentheses, then we just get the cosine of a 45-degree angle. And we should know, using the unit circle, that the cosine of a 45-degree angle is just root 2 over 2. That's going to be it for this video. Thanks for watching.